So the first question asks you to evaluate. If you remember what we said the other day, evaluate just means work out. Okay? So we're evaluating this equation on a calculator. To do this, it's got a fraction in it. Use the fraction button. Okay? So the fraction button on your calculator, you press that. Okay, you press that first, almost like you're saying we're going to be doing fractions. Okay? So on your calculator, you press that button. Okay? And then you type into the top the cube root of 90. Okay? Cube root on the calculator is above the square root button. Okay? So the cube root button is above the square root button. So you have to press shift and then square root button will get that. So your first thing, you're going to be pressing different buttons to get to start with. First of all, you press the fraction button, and then you press shift and the square root button, it'll get your cube root. Type in 90 underneath it, then you go down to the next one and type in as you see it there. The best thing about doing it with a Casio calculator, on the screen of the calculator, you will get exactly as it says there. Okay, it's designed for that. It's designed so you can see exactly as it is there. Okay, when you press equals then on that, you get an answer of 1.62369737. That's 1 mark. Write down everything there. Okay, so you get the 1 mark just for writing this. Remember then, the answer, look in the answer, read the question, it says to 2 decimal places. And for this, you look at question number, you pick the second number after the decimal point. Imagine there's like a line between them, right here. The number after that was 5 or above, that goes up 1. 4 or below, that stays the same. Okay? And then 1.62. Okay? Just as a note, when this happened in this question, I had to check it because normally, when you round up, the number does actually end up going up. So if it does stay the same like you did here, just check your answer again. Okay? So if it does stay the same, if you're not rounding up, please check your answer just to be on the safe side. Okay? Well, the next question, factorise the expression 18 minus 9y. What you do, you look at the two terms. Sam?
I got a different answer, which can still work, can't it?
Yeah.
So
All right.
got the 3, 6 one.
Okay, let me talk about that bit a second first. Right?
7, 8, 3, 5, 6, 4, 6, 4.
No, Sam means this part B now.
Oh, yeah.
Yeah.
I got the wrong answer.
I'll check for that in a sec. Okay? Oh, Mr. Ashmore. Okay, for question B, I'll talk about what you say in a second, Sam. All right? So what you do, you look at 18 and 9. You look at the biggest number you can divide 18 and 9 by. It's got to be the biggest number. Okay? The biggest number I can divide 18 and 9 by. Like Sam said, you can do it by 3. But the biggest number you can do is by 9. So 9 is the number that goes in front of the bracket. Then you say to yourself, well, 9 times what is 18? So there's your 2. And then you say 9 times what is minus 9y? So it's going to be minus y. Okay? What you did, Sam, it's called partially factorising. It means you factorise it, but you haven't gone as far as you can go. On a 2-mark question, you would normally get 1 mark for that. But if it's only 1 mark, unfortunately on this one, you get nothing for it.
I get nothing for that.
Nothing for it, sorry, Sam. Okay? And the thing to do is when you look inside your bracket, almost look at it and think, could I factorise that again? You know, like when you're simplifying fractions and you look at your answer when you simplify a fraction, you think, could I simplify that a bit further? It's the same sort of thing you do. You look at it and think, could I have gone further? Could I simplify it again? Could I factorise it again? Okay?
Sam, can I jump in very
Go for
quickly? You missed a really good example of that in the first paper we did, so if you watch back this morning's session, I'll share it all with everyone through email, whatever.
Okay.
Where we talked about loads of different answers you could have, but it was only the one with the 9 in front of it because it's what we call the highest common factor there.
Right,
Okay, a really good point.
Okay, part C. Like Mr. Ashton was doing this morning, when you're substituting into expressions, it's worth putting them down and using the brackets. Okay, the first one we put in is 1 1/3. You can use the fraction button on the calculator to put 1 1/3. If you look above the fraction button, it's got above it, the fraction looks a little bit like that form. If you press shift on the fraction button, it lets you easily put 1 1/3 in. Okay? You close brackets, and then you put at plus 2 times minus 1.8 in brackets. Press equals, you get 2 over 5 or 0.4. Both answers will be acceptable. And that'll be 2 marks for it. Okay, 1 mark for showing, one of the marks it says in the mark scheme is for showing evidence of substitution. So even if you totally mess up the next bit, the fact you've done this is you're showing evidence that you substituted. Okay? Okay, next question then. 3a equals 10. Remember, when we got 3a equals 10, this bit here, we're trying to end up, so we end up with a equals. The problem we've got here is to get rid of that a on its own, we want to get rid of the fraction first. So to get rid of that a on that side divided by a, you multiply that side by a, and whatever you do to one side, you do to the other side. So you multiply both sides by a, and you get 3 equals 10a. And then because you want to end up with a on its own, you divide both sides by 10. So 3 divided by 10, a is 3 over 10, or 0.3. Okay, so 0.3, so you say a equals 0 over 10, or 0.3. Okay? When you're solving an equation, whenever you see brackets, so like that first question on the exam yesterday, whenever you have brackets, expand them. Okay, you always get a mark for expanding brackets. So what we'll do here is 3 times x and 3 times minus 2 gives us 3x minus 6 and x plus 2. So you get a mark for expanding brackets. We got now an x on both sides. We need to put the x's on one side. The best way of doing this, look at both values of x, coefficient, the number in front of x. We put the x's on the side with the biggest value of x. So we're going to put all the x's on this side. So to do that, we get rid of this x here by taking it away. Whatever we do to one side, we have to do to the other. So we end up with 3x minus x is 2x, but minus 6 stays the same, and the 2 stays the same. We haven't touched that. And now we got 2x minus 6 equals 2. So we want to leave the x on its own, so we add 6 here, and again do the same to both sides. So we end up with 2x equals 8. And if 2x is 8, 2 times what is 8? So we can divide both sides by 2, so we end up with x equals 4. Okay?
So, first question said, write down the value of the oldest car. Now it's very important that you're really specific here. You need to work out the scale that we're going up in each little square. So you're on 0 here, you go up to 2000. So it's a jump of 2000 here, so 2000. And there are 10 little squares that feed into that. So that tells me that each little square is worth 200 quid. Okay? So the oldest car is this one here. And that was 4,000, that was 6,000. So in the middle must be 5,000. So then I've gone up 200 quid, so 5,200, then 5,400. I saw a couple of answers as I had a quick walk around and said 5,500. It's really important it says 5,400. 5,500 will be bang in the middle of that square. Okay? Your eyes are half the age of mine, they should be twice as good. So zoom in with your little eyes and see what it is. Yeah. So, 5,400 for that one. By eye, draw the line of best fit. When we're doing that, you're expecting to see roughly the same amount of points each side of the line. So we've got 1, 2, 3, 4, 5 here and 2 here. But that's pretty close. It's sort of like the one we looked at this morning that I drew. That was absolutely fine. It follows the general trend of the data. It doesn't need to be going through 0, 0 or anything like that. And it can hit the axes wherever. It doesn't matter. It doesn't need to be going through a specific value. And then finally, it says, use your line of best fit to estimate the value of a 3-year-old car. So you need to come up from 3 years, hit the line, and then come over. And you can see here we've worked it out by finding 7,000 in the middle and going up 3 squares. 1, 2, 3. So then 200, 400, 600, 7,600. What's the boundary? As long as you're reading it off your line correctly, it doesn't matter because your line might be slightly different from mine. But what you should be getting somewhere around is about 7,800, 7,400. Yeah?
What it says in the mark in this. It's just like the other questions we've done in this style with fuel bills. Okay? So this could have come in Unit 1 because it's talking about real world maths. Okay? So fuel bill, it says Mr. Jones is paying for his gas by 12 equal monthly payments. Each monthly payment is worked out using the following information. So Mr. Jones uses 15,000 units of gas in a year. The cost of the gas is 4.028 pence per unit used. There's a fixed charge of £6.98 per month, and there's a discount of £48 per year. So the way I did this is I just took information bit by bit and just worked it out. And again, because it's QWC, you don't have to go to town on the words. And for me, to show myself what I'm doing, I like to write it as I'm doing, otherwise I'm going to lose track of it. Okay? So what I did first, I said the cost of the gas. So if we meant just use 1 unit of gas in a year, we just spend 1 unit, 4.028 pence for that. If we had 2, we'd have 2 lots of it, 3, we'd have 3 lots of it. Altogether, we've used 15,000. So what we do is we multiply 15,000 by 4.028. And that gives us an answer of 60,420. But be careful, and remember, whenever we've done fuel bills in the past, they always do mix up the pence and the pounds. So that's going to be in pence. You need to convert it into pounds, so you divide it by 100. So divide that by 100, you get that they've paid for the gas itself £604.20. The fixed charge now, if you read at the top again, is £6.98 per month, and they've said he's paying into 12 equal monthly payments. So it's saying in the question it's for the whole year. So £6.98 times by 12 will get you, and it's in pound, so it'll be £83.76. Yeah?
I got 70 pounds.
What do you think? If it was £7, 7 times 12 is, I know, is 84.
Yeah.
So £6.98 is just under 7, isn't it?
Yeah, okay.
So it's a good way of checking your answers. Think, what would I expect it to be? All right. Your total cost then is these two bits added up. Gets us £687.96. At this point, if you haven't made these both the same units, that's when you're going to get difficulties. So always make sure you convert to pounds when you can. You then get a discount. The discount is not per month. The discount is £48 for the whole year. So we do this total, take away the £48. Gives us our final total then of £63.96. It's in bold at the top. They want the monthly payment. So the monthly payment, you divide that by 12 months, we'll get £53.33. Okay? That is enough for QWC. The grammar of the sentences, not important. The important thing is making it clear. Okay? It's the quality of your written communication. It's could someone look at that and see what you've done? And that's all you need for it. And that will get you 7 marks. Okay?
The key word in this question is group frequency diagram. The diagram in particular is key. That tells you it is a bar chart. If the word said a group frequency polygon or just a frequency polygon, it would be a line graph plotted at the midpoints just like we had this morning. Okay? So the key word you're looking for, diagram means bar chart, polygon means line graph. So you've got to get that into your head. Perfect. Okay? So from there, I need to do my frequency. It always goes up on the y-axis. I would go up in tens. A, because the top one was 80, so I had to go as high as 80. But B, because now my scale is really, really simple. 10 little squares go into 10, so each little square is worth 1. So the first one, I go across at 80, and I just draw straight down to 1 there. 0 to 1 doesn't go in the middle of the bar, it goes either side of the bars. It goes 0, 1, 2, 3, 4, 5, and it's just a bar chart for the rest of those values, and it should look something like that. Okay? Always important to label your axes. Frequency is fine there instead of number of pupils. And then time taken in hours or time is fine. Okay? Over the page. So, in terms of what you need to do here, thank you guys. Midpoint here is the middle of these two numbers. So the middle of 0 and 1. What I would always recommend you do. Are you listening? Still waiting? Lloyd? Thank you. If you're unsure how to work out the midpoint, add together the two numbers. I mean, here they are quite easy. 1 add 2 is 3, half that is 1.5. But if it was like 18 to 27, add the numbers together and divide it by 2. Underneath this midpoint column, though, what I would do or recommend doing is shading out underneath it so you don't accidentally add it up. That is the main mistake that will happen with this question. Okay? So if you shade out underneath it, Hopefully that will stop you from accidentally adding that up. Okay? So, midpoint column,
So they all 0.5.
they're all 0.5s, yeah.
Because it looks like a 6.
It's not the clearest, yeah. The other column you make is called midpoint times frequency. Now you'll see here in brackets, I've written F, and here I've written X. So just to shorten that down, instead of writing midpoint times frequency, I'm then able to write just Fx, F times X. So 80 times 0.5 gives me 40. 60 times 1.5 gives me 90. 52 times 2.5, 130. 32 divided by the 3.5 gives 112. And 16 times 4.5 gives 72. Okay? What you need to do next is you need to add up all of this column here. So you put that into your calculator. 40, add 90, add 130, add so on. And you get 444 by here. And here you add up all of the frequency and get 240. So to work out the mean, you don't need to write down this formula, but if you want to have something to remember, it is the sum of the midpoint times the frequency, so all of them added together, divided by the sum of the frequency, divided by how many there are, okay? So divided by the 240, so 44 divided by 240 comes to being 1.85 hours. And that answer should be somewhere between 0 being the slowest, or the quickest, and 5 being the longest. It's got to come between 0 and 5, and that number does. In terms of the last bit, it says, write down the class interval that contains the median. To find the median means the middle. So if I do 240, i.e. the number of people that were there, half of that is 120, I'm looking for where the 120th value is. The first 80 people are in this column here, between 0 and 1, but then the next 60, so that's a total of 140 people, are in this next column here, so 1 to 2. So 120 is underneath that 140 that those two add up to make. So the median value must be in this group here, 1 to 2. Okay?
What you need to do, what you need to do is it's different to a normal ratio question because instead of saying we're sharing £30 in that ratio, read what it says. Gethin and David are sharing it in the ratio of 2 to 7. David gets £30 more than Gethin. So remember the ratio, the order of the people. So the order of Gethin and David is the same order as the ratio. So in this bit, David gets £30 more. So how many more parts does David get in the ratio? If Gethin gets 2, David gets 7, David altogether gets 5 more parts. And you know the 5 parts is worth £30. So to find out what 1 part is, which is all we're doing in ratio questions, if we find out what 1 part is worth, so 30 divided by 5, each part is worth £6. So they want to say the total of the money the brothers share. So it doesn't ask for how much does Gethin get, how much does David get. It just says what is the total. Okay? So total number of parts is 9. Each part is worth £6. So you do 9 times 6, gives you 54. Okay? You know it's Pythagoras because we've got a right angle triangle where we know sides and there's no mention of angles. Okay, so we know it's Pythagoras. And we're trying to find the length. Well, actually, we're trying to find the total distance. To find the total distance, we need all the numbers, don't we? So to find total distance, we need to find the missing distance here. Like before, I put that as x, because it's like just as I'm used to putting that as something I'm trying to work out. Okay? So what you do, we need the unknown side here. And I should put an end at the end of that, never mind. It's a right angle triangle, so no angles, so it's Pythagoras. And what we do is we write down x squared equals 8.5 squared, add 7 squared. So we work that out with a calculator. You get 121.25. Remember to look back at your answer. Look at this. If we ended up with a value of x of 121, look at the other two sides. They're much bigger than that. It's much bigger than that. It's going to be bigger, but it's not going to be much bigger. Okay? So check your answer. Look at your answer. Remember, in Pythagoras questions, you must square root. Okay? So you square root your answer. We get an answer of 11.01. Just round it there. Then a total length then is you add all around the outside of the triangle. So 8.5 add 7, have 11.01. Gives that answer of 26.5 kilometres. Okay?